Good morning, everyone. How's everyone feeling this morning? Good. There's a mad delay on this thing, so can you guys fix that? Okay. All right. Yeah, and any technical people in the room? My name's Mike Hardwick-Brown. I'm your session facilitator. I'm here to tell a few funny jokes and introduce AJ here, who's going to do our chat. Does this thing still work? I'll just talk loud. I have a couple housekeeping items to go over with you first. First of all, good morning. Lunch, same place, 12:15 down in the expo hall. And then another question. Anyone Harry Potter fan here? Okay, well, Jane McGonigal is signing books. Where is she signing books? In the expo, starting at 12:15. So you can go get a book signed by Jane McGonigal, Professor McGonigal. Not my best joke, but anyone that signed up for the Elevate Luncheon, that's taking place at 2:15 to 2:45 in the Shaw meeting room on M3. And lastly, the speaker evaluations in your app. We're really excited about these, really hyper about them. We really want you to fill them out. And with that, that's all of my housekeeping. I'm going to welcome AJ to the stage for continuous validation.
All right. It's on. Okay. All right. Thank you for coming to my talk. Today we're going to be talking about continuous validation. Don't fire. All right, that worked. So quick background on me. I've worked in several different areas of cyber, done malware remediation at ESET, security administration at university, and gone all the way down the line to leadership, doing all kinds of things along the way. So I've felt the pain of this specific topic quite a bit, especially when I worked at the MSSP. Today we're going to be covering, first off, we'll just sort of quickly go over a situation, complication, question, kind of covering what we want to talk about, why validation matters, the pipeline and stages, so this is the idea of sort of using a CI/CD pipeline for your detections. And keep in mind there's a ton of ways to do this. This is just one specific method that I'm showing you. And then we'll talk about the questions that pipeline answers for us, and then we'll kind of dive into certain areas of the pipeline, dig into tools that work for you in that area. Talk about a couple of examples in the public that you can use to sort of build your own pipeline. Putting it all together, challenges, solutions, some key takeaways and questions. So the situation we're talking about here, new detection engineering teams will often manually create their rules, right? So they stand up a SIM, they start deving the rules and throwing them in there. They're excited to start detecting stuff. But those rules just kind of exist. They don't ever get looked at again. They're not iterated on. They're not getting feedback on them. They assume they work because they went off someone's blog post that said they should look for this stuff. And then the complication, it sits there. It becomes unmanageable. There's false positives. There's rules that aren't working, but they don't know that. And they end up having this huge library that they're struggling to manage because half of the rules were created by people who don't work there anymore. And there's no documentation or anything. The question, we want to know how can we be sure that your detections are providing value, making sure they're validated, and that when someone asks, are you going to detect this threat that's in the news, you can confidently say, yeah, I know I'm going to detect that because we have these specific rules that are being tested and validated regularly. So the bottom line, right, adopting a detection as code approach is going to increase your confidence in your detection library by reducing human error and validating the detections against attack data. So why does validation matter? Well, according to a recent data breach analysis, IBM found that it's roughly $4.5 million, or $4.45 million is the average cost of a data breach. So, I mean, that's not great. And then there's been a 13 time to detect, and then only 24% technique coverage across tools usually. So these are not super, this isn't a good look for detection. And this is something that can be somewhat solved, I think, by validation, right? Some of it might be the fact that people don't have verbose enough rules or enough rules, but part of this, I believe, is because validation is pretty lacking in our industry. I have my obligatory memes for a cybersecurity conference. So this is just an example of how human error, right? Like you look at this detection, and if you look at it long enough, I'm sure most of you will find all the problems, but some of them are very subtle and they're very easy to make. So you might look at your alerts, and again, 0 alerts, does that equal 0 problems? Honestly, usually not. Oftentimes there's probably an issue. So if we break it down, right, this rule alone has all these different errors, right? Command line has an underscore, it usually shouldn't. They're using a single quote. The backslashes, that one gets me all the time. I'm more of a Linux user, so when I'm in Windows, I'm often pounding my keyboard because I'm using the wrong slash. But this is just an example, right? These are all like pretty simple things that some sort of unit test could definitely catch, but a human might easily overlook this if they're just writing the rule normally. So let's break down sort of the stages that you might see as a company getting into this validation process. First, again, this is that company who's like, all right, I'm super pumped, we got a SIM, I'm creating rules and we're just chucking them into the SIM, we're protected, we're killing it. Issues you're gonna run into here, syntax, right? Easily, like we just saw, syntax is gonna be a problem. If you don't validate, you're probably gonna be deploying rules that have syntax issues. You're probably gonna have false positive rates that are getting crazy because you have no analyst feedback loop. You don't have any other validation against attack data validating that the rules actually work. Like I said before, the original rule developer might leave, and then people are like, what is this rule for? It's just a rule full of hashes or a rule full of IPs. We have no idea what they're for. And you're trying to figure out, like, why was this created? Do we even need it? Nobody knows. And then again, no versioning. That's another one, right? If someone makes one little change to a rule, they can blow a SIM up. And if there's no versioning, you're just trying to figure out who the heck made that change and why did they make it. But now we go into step 2. This is where the company's like, all right, we're going to set up, again, one method of an automated pipeline. This is just, if you're a developer, you probably recognize this from like Git. The idea of having that workflow. So you have your main or your dev. You probably don't need that. You could just do main. But then at the top, it's like the developer is cloning and checking out their branch, creating the content for their product, and then pushing that to their remote repo and doing the PR, and then it's getting auto-deployed and all that through Git actions or whatnot. So this is good, right? You're getting versioning, you're getting some tracking of your rules, but there's still not any sort of automated validation here. So you're still going to be running into a lot of the issues from before, but you'll have better sort of tracking of your rules. Next, you'll see the boxes here pop up. Right now, we're inserting some validation, so syntax, baseline, attack data. That top one says optional. That's just because you'll see in some repos they'll have the ability to run validations on your local machine. So as a dev, while you're deving, you can validate. That way, you can make sure, or hopefully make sure, that your stuff's going to validate when it gets PR'd. And even with this, like, this is great. You're going to have a lot of success with this. Downside, you're still not having post-production deployment validations in place. So because you don't have that, you might run into issues where everything got tested and looks great in your pipeline, but now you push it to prod, and all of a sudden a logging issue comes up that you didn't realize happened, and the rule still doesn't work. So that's where we're going to want to add this last piece here, which is the post-deployment. That gives us analyst feedback, having some procedure in place to make sure that your teams are communicating, and the analysts and detection engineers are constantly like iterating on these rules and making sure that when we are pushing rules to the analysts that they're using and looking at all day long, we're actually getting feedback from them, because they're the ones who are going to see it and be like, hey, this triggers all the time and there's so many problems, and we're over here in our lab like, we're killing it, these rules are the best. And so you want to make sure that you're constantly talking to those analysts. And this might differ based on your structure, right? If you don't have an analyst detection engineer split, maybe it's one person who does it all, that it's a little easier. And then attack simulation. That's important because being able to run attack scripts to actually validate in production helps you also validate that your logging is working properly. Extractions are working. The field names aren't changing. There is the possibility that a log source updates and then all of a sudden the logs change and break a rule. So things like this type of attack simulation are going to make sure that those work, which might not do as well with the attack data, which we'll talk about later. So the questions that these are sort of the questions that pipeline is going to answer for us. So the syntax validation, that's going to tell us, is the rule technically functional? So we want to know, like, did I write it right? Is the syntax, the field names, all that stuff accurate? Then for the accuracy here of, was it actually going to detect the activity I'm trying to detect? So this can be attack data, this could be baseline data to say, like, maybe this will detect an activity, but it's also going to detect a lot of normal activity and be nuts. So that kind of gives you that baseline there. And then going through all the way to the right, there's the, is it logged? Is it in that SimEDR? Is it functional? And is it ultimately effective? That's going to be all the like attack simulation stuff, where you're making sure that when the attacks are ran or the scripts are ran, the rules are actually picking this up. And then again, at the very end, that's the analyst feedback, where we're looking, is it ultimately functional? It's gone through all our checks, it's made it all the way to production, and it's now triggering detections. So are we hearing from the analysts that, hey, these are good detections we're actually able to action on, or are we just getting flooded? So now we can dive in and sort of talk about some of the sections in this pipeline. This top section, again, is the detection engineer pulling their own branch and starting to do development. And so this is where, if we flatten it out into a more simple sort of framework, we'll see that the thing the detection engineer is going to do is they're going to look in the backlog, right? You might use Jira, and they're going to go in there and say, okay, so like, what are we looking for? What should I prioritize? What did Intel feed us? They're going to grab that item. Hopefully they're going to be able to do some research on it. And so personally, as a detection engineer, I prefer to be able to actually execute the malware or run the attack chain that I read about, so that I can get the actual logs to work on to create my detections. I found that just to be significantly easier than trying to read a blog post that's not super specific, or trying to do it without logs. So some of the tools that you can use here, Attack Range from Splunk is a really good one. It's still actively developed, and the team at the Splunk research team are just absolute wizards. So this is a really good one to use. Detection Lab's also great. It's not maintained anymore, which is a bummer, but it's still really great. So if you're really good at using Terraform and other tools, you could fork it and kind of maintain it yourself. And then Simulan, that's another one that I've never actually used, but I've seen other people use it. And then you would move on from there. After you are able to actually execute the activity and get the logs, you'd go into developing that detection. And ideally for this pipeline, right, you're going to be using something like Sigma, because you need to be able to write your detections in some format that can actually be translated using code and like pushed into a production environment. Sigma is sort of the standard that you can use, but other people might create their own syntax or schema that they use. This is just easier if you're getting started. Start with Sigma. It's a really great community, and they already have a ton of detections in there. And then from there, you'd move into developing your attack script. And so I like to think of attack scripts sort of like unit tests, I guess. I don't know if that's the best term for it, but it's we have Atomic Red, Mandiant MSV, Caldera, Purple Sharp. There's a bunch. Atomic has a really strong community behind it. So I highly suggest looking at that if you're interested in getting something set up there. But this is specifically in the developer workflow. So the developer is deving their rule, and they're creating an attack. So you think of the pairing as the attack range is where they're gathering the attack data for validating in the pipeline. Sigma is where they're writing that rule. And then Atomic Red is where they're creating the attack simulation that's going to be used in post-deployment. So those pillars are sort of like infrastructure as code is going to be the Splunk Attack Range, right? So here's an example. It gives you a Python script that they wrote that allows you to quickly spin up a range in AWS. And then you can have it simulate, run the attacks. You can have it do like replay log data if you already had it. You can have it dump the log data to then take and put into that attack data pipeline that you want to do. So it just it allows you to kind of manipulate the lab using code, as opposed to having to manually like set up an AD environment all the time. Detection as code, right? This is the Sigma. This is how it's going to give you that format, that YAML format, where you can write the rules that code can easily kind of manipulate and translate and deploy. And then as attack as code, same thing, right? It's a YAML format. They go by technique, MITRE technique. So you'll have like a technique with a bunch of attacks in it. But if you create your own, you can do it differently. So Now we're going to dive into the actual testing in those in the pipeline, right? Where you PR it and then it kicks off Git workflows and whatnot. So obviously there's for the PR stuff, it's GitHub and GitLab. GitLab, I guess, is merge request, but you know. And then from there, it's going to move into that syntax and baselining. And so this is going to be things like linting, if you're using YAML, linting it. If you have some specific schema, maybe running some sort of schema check on there, making sure it aligns. EVTX baselining, this is something we'll briefly touch on later too. This is something that Sigma does where it uses some EVTX baseline log data that was created by Nextron Systems. So they have a repo where it's like different versions of Windows and admin activity. It's just a bunch of logs of normal activity. And so they pull those in and they're able to run the rules against them to say like, are these rules gonna go crazy on just benign activity? And then custom tests. You're gonna see in some of these repos that we go over, they have a bunch of scripts that are doing all kinds of tests. And this is gonna change if you're building it specifically in your environment. You might have other custom tests that are specific to your environment, right? Maybe you have a specific log source, or you have a specific configuration or some sort of standard you want to keep. You're probably going to want to write unit tests around that so that as it goes through the pipeline, those things are validated and you don't have a bunch of rules that are just all over the place. Then we have attack data. Again, this is attack data Splunk. So when you saw the dump command from attack range, that's how you would get some attack data. But they also have a repo of a bunch of attack data already gathered. So that attack data can be utilized to validate the rules to make sure they're actually going to detect the attack activity. One of the things, so at the end I have a link to a post I made that's just a bunch of links, a reading list essentially to kind of learn more about this stuff. But the attack data is interesting. Splunk actually, their research team did a 4-part blog about their whole process of trying to create a validation pipeline. And they actually came to the conclusion that they were trying to use atomic red, I believe, but they were trying to do that in the validation pipeline to say, hey, we want to validate all our rules at once. And trying to do that with attack simulation is actually quite difficult because say you're trying to test 500 rules, you have to deploy a bunch of attack simulations that might utilize specific configurations and systems, and it gets crazy and it can take a long time to run and very difficult to troubleshoot in a pipeline. So then they realized, okay, why don't we just do attack data? We can execute multiple Splunk instances in Docker and feed them. I'm getting ahead of myself. So we'll talk about that later, but that's what they do with attack data, and it's a really, really cool project. And then there's compile and deploy. We're not really talking about deploying because that's sort of custom too, but PySigma is the new, took over SigMac for the Sigma repo, so that's one way to manipulate those rules and create the pipelines, and they also have like templating for creating Splunk rules and stuff. So it's really a neat new feature here, much better than SigMac. And then the feedback and attack simulation. So this is, you see the same products as the developer process. And that's because, again, the developer was creating that attack script. So then now, during this attack simulation, there's a script to be ran. And then the processes and procedures. That's going to be a lot more of making sure, building a culture of communication and a culture of getting the teams to talk together and actually iterate on these rules together rather than getting overwhelmed and just sort of putting their head down and closing rules without saying anything. So back to that pipeline right now, we're seeing some parts of this get automated. The only reason I say that one piece is partially automated is because when you run the attack simulations, it's very much, you run the simulation and then you're gonna have to validate that against your detection. So okay, I ran these simulations, did the detections trigger that we're supposed to? You can automate that. It's not, I don't know of anything out there that already exists to just like out of the box easily pull those in and tell you which rules we're supposed to validate and give you a report. So you might have to build that yourself. If someone knows a product out there that's open source that can do that, let me know. So that's the only reason I say partially. So unless you build that into the process, it's still going to be somewhat a little bit manual there. So let's dive into a couple examples here. This is the Sigma repo. Again, Sigma is by Florian and Nas and all these really, really smart guys. And Thomas is the one I think who created it, but this is their repository and kind of how they do their testing. They use, again, like I said, they have multiple scripts that are doing all sorts of different tests in here. So the validate script they're using to run, and like I was talking about, check that Sigma schema. So you can see I wish I had a pointer or something, the bottom left-ish box there, you can see where there's the Sigma schema check.json. So that validate script is using that JSON standard to validate the rules and make sure that they're aligning with the schema that's expected. And then they have the check baseline. That's the one I talked about with the EBTX baseline, right? So it's pulling that data from the Nextron repo to take that baseline data and check it against the rules and say, hey, are any of these rules that are getting committed to us like absolutely bonkers, or are they going to work okay? Next is like the test log source. That's just a Python script that's looking for log source field and field name errors. So it's just checking, like, as you see people develop and things get into production or get past the validation pipeline and you find issues, that's when you want to go back and add it to these types of scripts and say, oh, people are mistyping names of log sources. Let's go back and add some checks in there to make sure that these are aligning. And then testing the rules, looking for non-compliance and common errors on the rules. Again, you're going to come up with these errors as you start to like kind of be in this pipeline a little bit and start noticing problems that slip through, and you just keep iterating and making it stronger and stronger until less things make their way through. The next repo is the attack data. This is actually from the Splunk security content repo. And this is what I was talking about with their blog post. They came up with the Docker detection tester, which is the way that they found was the most efficient to actually validate their whole rule set against attack data. And so the way this works, well, you can read the bullet. I don't want to read every slide, but they essentially spin up multiple Docker instances using the Git workflow, and then they install the apps on all the instances and do all the testing so they can split the rule set out into multiple instances. So instead of running them all on one and it's taking forever, they just split them out and then it runs faster because they're all running in unison and being able to test all those rules a little bit more efficiently. Again, I'll share those links at the end. They're very interesting blog posts I highly recommend you read. So if we put this all together, we have, very simply, this is somewhat oversimplified, but if you're using GitHub or some Git repo, you store the rules in that Git repo in a standard format, so Sigma and whatnot. It's something you create. Next, you would create GitHub actions and scripts to test the rules on pull requests. Then you'd create the GitHub actions and scripts to compile and deploy, and then you'd regularly run attack scripts and validate and get the analyst feedback. So this is like that whole process, very simply put into 5 steps. Obviously, there's a lot more that goes into it in between there, but at a base level, this is kind of what you need to conquer to get to this point. And there are challenges, obviously. This is not a very simple or straightforward thing to build, but the challenges here, you need a team with coding and Git knowledge, which surprisingly, I've actually worked with a lot of people in this industry that don't know how to code and have never used Git before. So this can be a challenge. If you're trying to spin this up and your detection engineers, specifically, they just use SIMs all the time and they've never actually dabbled in code or anything, that can cause this to be a difficult thing to set up. This also adds a little bit to the plate of the detection engineers. I remember like when I was first just developing detections, it's a lot easier to just make a detection and put it in and move on to the next one. But then when you get to the point of like, okay, well you actually need to like gather attack data and write a validation script, it increases the complexity of the job of the detection engineer, because writing validation scripts can be complicated, right? You're standing up a lab, you're having to make sure it's configured correctly, you're gonna have to be the attacker, right, writing these scripts to actually function. So there's a lot of troubleshooting and stuff that comes into that. So this is something to look out for. That's a little bit of a learning curve too if the person's only a blue teamer or they've never done any kind of attack. And then, right, pipelines are complicated. So I've seen before where people get these pipelines set up and they're super excited about it, and then the person who was sort of the main person behind creating that pipeline leaves, and they're like, how do we maintain this pipeline? I have no idea how this works. And then, of course, there's no documentation, so they're fumbling through trying to figure out how to get this pipeline working, running into issues, and then eventually they just stop using it because they can't figure out why it's not deploying the rules anymore. So that can be a challenge. And then, fixing it is challenging, but also testing the rules in production. That's something that's adding another thing to your team's plate. You're going to have to schedule out, like, when are we going to run these attack scripts on our environment to make sure that the rules are working in production. So this pipeline's great and it gives you a lot of confidence, but it does add a little bit of extra work there to the team. So you'll want to keep that in mind. Some of the solutions, as I was kind of looking through this, is like, honestly, you can invest in the continuous learning. Everyone I've ever met in this industry is kind of obsessed with learning. So I don't think anyone would ever be say no to being like, hey, I want to pay for you to learn new talents. You can have them collaborate. If you have actual developers in your environment or at your company or a DevOps team, you can have them sort of collaborate together, maybe build some bridges there where they can help each other and learn from each other. Leaning on community products, honestly, that one's huge. Like Atomic Red and Sigma, again, they're massive, or really, really big communities and really smart people in there that are always willing to help. So I highly recommend just getting involved in those communities. And then creating a culture of documentation. So, I mean, I'm a huge fan of writing. I think that writing is, like everything we do is downstream of writing. So getting a team, encouraging a team to write and document is important because one, you're sharing that knowledge with other people and you're creating a little bit more resiliency in your teams, in your team. And then also the writing just helps them process things better, right? So you might have seen the Palantir ADS framework. I think that's brilliant because that's getting people to actually write things out as they're developing a rule rather than just sort of like on a whim. I read an article, I'm gonna like throw something out there. It forces them to think through it and actually write out their thoughts. So highly recommend like encouraging writing is something that your team invests in. And then creating a culture of automation. Like I talked before, if you're creating this pipeline and then you don't ever touch it again, you're still gonna have issues sneaking their way through. So it's important to be able to say, instead of just kind of fielding those issues manually as they come through and having to like continually solve the same problem, actually automate it, right? Create a unit test. As you detect issues, solve it with automation. Go back to the pipeline, write a script or add to a script to make sure that that thing is getting picked up and fixed next time so you never have to deal with the same issue twice. And then setting aside dedicated time for the attack scripts is, I think, extremely important. I've seen before where a company's like, yeah, we're going to do attack scripts, so-and-so, that's your job. And then the person's like, okay. And they have a bunch of other things on their plate, so they just never end up doing it. So unless there's like an actual like meeting about it where you set it out, schedule it, put it on the calendar, make a plan, it's really easy for that attack simulation piece to sort of fall to the wayside and not really happen. So staying vigilant with that, I think, is very important. And then, honestly, if you don't have the ability to run this, because this is complicated, and if the team, you don't have the skill set or the size of the team or the time, like there are vendors that can do this. So I highly recommend looking for vendors. I mean, obviously, SnapAttack does something like this. So if you want to talk to us, you can come talk to us at booth 206 and pick our brains. But yeah, it can be complicated. So I don't know where the title is for that slide, but that's all right. So basically the key takeaways here, right? 0 alerts that doesn't equal 0 problems. I think we all kind of knew that, but that's just the truth. A validation pipeline is going to increase your confidence in your detections. CI/CD workflow via GitLab is just, or GitHub is just one way. You're going to want to build something that works specifically for your environment, because every environment is different. And then utilize those community projects to make sure that you're getting involved in them, because they're super powerful. Lots of smart people that you can pull from. So yeah, definitely do that. And then automation and documentation, extremely important. And then again, learn from what's been created. Don't try and recreate it. I mean, unless you have the time to do that, but most of the time it's better to just learn from what's been created and iterate on it. So I appreciate you coming to the talk. This is, I'm AJ King, Director of Threat Research. The reading list, you can just go to ajking.io/mWISE, and I'll give you all the links of people much smarter than me who wrote blogs. So highly recommend reading those if you're interested in getting into this. And yeah, thank you for coming to the talk. Any questions?
All right, if anyone has any questions, just raise their hand. Oh, almost.
Dang it.
Thank you. Great talk. Can you go over one more time the difference between the validation and the section before where you're, I guess, running it through normal logs?
Yeah. You're talking about like the attack simulations versus so there's the validation that is essentially like unit testing and coding. So essentially in the pipeline during the PR, that's when it's going to be running those unit tests against the rules, saying, is the schema correct? Are there any like typos? Are there any issues in the rule itself? That's making sure it's accurate and actually written properly. And then there's the attack data, which is running the rules against actual attack logs. So you can say, hey, I ran this rule against that attack and it detected it. I can guarantee that it detected it, right? It passed the pipeline. And then the post-deployment is the simulation, which is running attack scripts like Atomic Red. And those are actually, instead of just replaying logs, those are actually running the attacks on a box. So the logs are getting regenerated in the sim, and you're able to validate a little bit more of that process.
Thank you.
Yeah.
Great talk, AJ. So for those that are interested in getting involved in like the Sigma community and Florian's kind of access there, where can people start? Because I think that's important.
Yeah, so they actually have a Disney, really, really cool. You can go into their repo and they'll accept, pull requests from anyone. So if you have something you can fix in there, definitely do it. And also, I mean, we pull in the Sigma repo into our product, so you can go in there and get a community account to see their rules and the validations that we do on them. But yeah, it's an amazing community. You can also follow like Florian and Nas on Twitter. They're very active and they love memes, so it's a good place to see them.
Hello. Hi. Hi, thank you. Great talk. So I'm wondering if you can tell us if you had experiences on behavior analytical based use cases. Because Sigma, like as far as, to my limited knowledge, is a lot of key and valid pair and IOC or keywords matches, pattern matches. What about behavior analytics? Like, have you ever, run into a case where you need to observe heuristic behaviors and then turn that into a signature and then validate that? Because, I struggle with this on a daily basis. We have a lot of validations, but when it comes to behavior heuristic, like, it's kind of have to be 100% manual. So thank you.
Yeah, no, that's a really good point. I haven't done a lot of like the data science detection with trying to use that with Sigma, but I know Sigma's working on more of the cross correlation. So being able to create rules where you can actually identify this rule is just an event that's going to be triggered on by another rule. So then having another rule you write that says, all right, I'm looking at these other base events that I triggered and trying to like sort of make it more granular and do more cross correlation. But as far as actual doing more of that data science work, I've never tried that with Sigma. That's usually something I've seen in other products before that are utilizing actual like data science backends and models and stuff like that.
All right, last call for questions. AJ, great talk. Thank you very much.
Thank you.